All right. Well, let's take a look and see what our programming class is this week. We did go to the movies, though. Gosh, that was Friday. I've forgotten what we saw, Andy. All right, now I got to look up. It's driving me crazy. I enjoyed it, but I don't. Gosh, when things come at me. Roof Man. Yes, we saw Roof Man, which is based on a true story of a guy that used to break into like McDonald's through the roof. He'd tear a hole in the roof and go in and steal the money. And he's like 49 different McDonald's. And they were about to catch up with him. And he went and he hid in a Toys R Us for like months, right in the middle of a Toys R Us. There's a place behind the bicycle where there was a big display and it's real tall. And he could get right in the middle of it because it was hollow in the middle. And he lived there for months. It was kind of crazy, but it's based on a real story. So it's like, that's pretty cool. So it was a good movie. It's a better movie if you don't see the previews because the previews almost show you all the good parts. I hate that. Okay, let's see what we got this week. Going to our grade screen, we finished 2.01, 2.02. So now we are looking at input and selection structures, 2.03. This is a short week. I'll remind you of that. Oh, wait a minute. That is wrong. I don't get to do that very often. This Friday, we don't have school. So there's nothing. No, Thursday or Friday is fall break. So there's only classes on Wednesday for any asynchronous classes you may need to be in. But yeah, that felt kind of good. Just take it down. All right, let's get back up to this. Yeah, I was going to do it Friday and forgot about to do that before I left there. Let's see, 2.03. Let's go take a look. Going with the flow. Gosh. All right. So far, you've been programming a series of statements in exact order. But what happens when you want to change the flow of your program? So there's certain situations where you might need to make selections depending on different conditions like the user input. So we can use flow control for this, controlling the program execution sequence. If statements are one example of flow control. Perhaps you've thought, if I vacation near the ocean, I'll buy a surfboard. Or if it's raining, I'll buy a book. Or an umbrella might work better, but that's just my opinion. These are all real life examples of programming if statements. In Python, an if statement says if the condition is true, do something. Otherwise, don't do anything. There's if else statements. You can increase the functionality of an if statement by adding an else statement, creating an if else statement. These mimic decision making in real time. If the pizzas are buy one, get one free, then I'll get two pizzas, else I'll just get one. In Python, an if-else pair says, if the condition is true, run this indented code block. Otherwise, run the block that's after the else statement. Then we have the elif statements. What happens when your program requires more than one condition to be met? For example, you can only rent a car if you're 21 years old, or if you have a driver's license, and if you have car insurance. Although a lot of these places are 25 years old for car rentals. Good news. In Python, you can do this by combining if and else statements using the elif statement, which is short for else plus if. And it's used when there's more than two options to satisfy. In Python, an elif statement says, here's another condition if all those other conditions were false. All right. Here's the flowcharts and how all of those kind of work. The if statement, we can make that a little bigger. We have a condition. If it's true, we run this code. Go on to the next code. If it's false, we just go around that code and just continue on with the rest of our program. So code that's only run if this condition is true. With the if else, we have this same thing. Is this condition true? If it is, go over and do this. If it's not, we have a different section of code to run. So you're going to run some code either way with an if else. If it's true, going to run this. If it's false, going to run this. Either way, we'll continue on to the next code after our loop. This other else elif. So if this is true, go to this block. Do that. If that's false, check this one. If this one's true, go do that block. But if that's false, go check this one and do that block. If they're all false, do this else down here And then either way, after you run whichever of those 4 blocks of code, you'll continue on with the program. Relational operators. When writing if-else statements, you often need to use these relational operators to tell the computer to search for logical connections between items. You know, those Boolean operators that we used last year. Let's see how this logic's used with conditional statements. If true, then what? You know, for a business that offers discounts starting at and above $50, if the cart total is greater than or equal. Remember how those things work. The not symbol is says if it's not equal, if that exclamation mark, that's what that exclamation mark is. Not equal. You know, 2 equal signs for checking to see if something's equal to something in Python. Less than or equal to, greater than or equal to, then you qualify for free shipping. If true, then what? If promo code is equal to, if you typed in say 15 as a promo code, equal to 2 equal signs, take 15% off the total price. Right. Next one. For extra large socks that start at size 12, if shoe size is, the XL sock will be too big. So it means if it's less than 12, because these are 12 and up, it's less than 12, it's going to be too big. If data usage is blank data plan, you pay an overage fee. If you use more than, greater than the data plan, it says the same thing every time. Our sense of logic is quite impressive here. If the credit card number is something 16 digits, then it's entered incorrectly. That's where you use that not. Your credit card number shouldn't be less than or greater than 16 digits. There should be a 16-digit code for a credit card. So, yep, you got to use that not symbol, not equal. For a mail carrier that delivers packages based on distances of 0 to 10 miles and over 11 miles, if shipping distance is something 10 miles, you'll get the package the next day. So I'm guessing 0 to 10 miles is today. Over 11 miles must be later. So greater than or equal to 10 miles, you get it the next day. Oh, try again. Wait a minute. All right. What am I missing here, guys? For a mail carrier that delivers packages based on distances of 0 to 10 and over 11. If shipping distance is something 10 miles, you get the package the next day. Not greater than or equal to. I thought it would be. I thought maybe this was day today and this is tomorrow. Maybe it's just, oh, it's just greater than. Not equal to, because 10 is included here. That was the deal, because this is 10 miles. It's just greater than 10 miles. Not quite. Oh, less than or equal to 10 miles. That doesn't seem right. What do you get it the next day? Oh, I guess maybe over 11 miles is like 2 days from now. There's no way you can have it delivered today. That's what I'm learning here. Oh, we got 5 minutes. That's all right. All right, page 2. We got to move on now since we started the wrong lesson. To test or not, to nest or not to nest. You can place or nest if and elif statements inside other statements. This enables the program to make complex decisions based on different inputs. Examine the code below and identify the nested if statement highlighted in the code. Then copy and paste the code into the course idle to see if your prediction is correct. Great. So we've got a main function. Candy cost equals an input statement. How much does the candy cost? So we have an if statement here that says if it's greater than or equal to 3, and if that's true, then there's a nested if statement. It's like, if that's true, I want to check something else. So if it's greater than or equal to 20, then. So if it's more than 3, check to see if it's over 20, because that's too much money. That's what we're going to print. That's too much money if it's over 20. But if it's over 3 and not over 20 or equal to, then I'll go ahead and buy it. It's like, yeah, I want a lot of candy. Well, I don't want to spend over $20 though. That's crazy. $20 a candy. And else print no one likes cheap candy. So let's copy this as they suggested and put it in our idle. Okay. So when we run it, pops up our window. How much does the candy cost? Let's say it costs $15. I will buy the candy. And they do have it as an integer, so it's going to give an error if we say it's $15.99. But what if it costs $2? Okay, that's that cheap little hard candies that nobody wants to eat that Grandma used to give out at Christmas. Right? Let's say it costs $35. That's a lot of candy. That's too much money. So that's a nested if statement. You got an if statement inside another if statement, which is very useful at times because you can see that situation. Yeah, but I want to buy at least this much, but not. I don't want to spend over that much. When you combine multiple if statements, they're called nested if statements. Just like items that fit inside other items, they're nested, like these nesting dolls that go inside there. Examine the code below to understand how nested statements work in a program. And then we'll copy and paste this. This got a lot of stuff going on. Oh, look at all these comments for us, though. Shipping equals integer. Please enter shipping distance. So this must be miles, I guess. So this is the first if statement. The program checks if the condition is true. If the shipping is less than or equal to 200 miles, we can ship your package because we got a local guy that has a truck. He'll take it from here. Then they have the nested if statements, if statements. These are nested in the initial one. If the shipping is greater than or equal to 150, so we know it's less than 200 or equal to. But if it's 150, it's going to be $100 because the guy's going to be driving for a few hours to get to you. It'll be $100. Then we can use the elif underneath that. So if this is true, but if it's not over 150 and it's just equal to 100, we'll charge $50. But if it's greater than 50, $25. If it's less than 50, shipping is less than 50 miles and it's free. So this is nice. We can only ship it if it qualifies for this. Otherwise, Brent, we're unable to ship over 200 miles at this time. Brent, goodbye. Print goodbye either way. But this is it. We're checking the first thing. If this is true, then we need to check some other things. How far is it? How much do we charge for shipping? Because we're delivering a table and chairs or something, right? So if it's too far, over 50 miles, then we're going to have to at least charge some shipping just because it's going to take a lot of gas to get there and the guy's labor. So let's copy this in here. Delete that. Paste this one. Enter the shipping distance. Okay, we're going to say we are 201 miles away. We are unable to ship over 200 miles at this time. All right, let's test the next condition. We're 185 miles away. We can ship your package. Shipping cost us $100. Goodbye. Yeah, the 100 was if it's over 150. So now let's check between 100 and 150. I am 111 miles away. Shipping cost is $50. Correct? Should be 25 between 50 and 100 now. So we are 88 miles away, $25. And if we're just like 12 miles down the road, we get free shipping because it's less than 50. Okay, so we see how all of those nested if statements work. Very useful. And there'd be lots of times that would be needed, different types of programs that we can do. Programmer Spotlight, Joan Ball, computer dating pioneer. Having been abandoned by her family and suffering from dyslexia, Joan Ball's story sounds more like a TV drama than one of a pioneer. Find it on the Hallmark Channel, right? But despite her rough beginnings, Joan went on to change the course of history, and she did it by thinking like a programmer. Living in the UK, oh, I'm sorry, Joan. Joan worked at a marriage bureau, similar to like a matchmaking service. She found that the better she could quantify her clients' interests, the better matches she could make. Sure. So she used that information to develop a format that could be used with a computer and then opened her own company. The rest is history. In 1964, she ran her first set of computer matchups, making her company the first successful computer dating service by creating a program to kind of check, do you have similar interests? Like she's a big vegan and he's a hunter. That's probably not going to work, right? Yeah, so There we go. The first computer, 1964. So 61 years of computer dating has been possible out there. Validating user input. Getting user input's great, but it won't do any good if it's not in a format that your program can use. Like that other was integers, right? So if I live 31.5 miles, it'd give an error. As a programmer, it's up to you to check your user's input to make sure they've entered information correctly. This will help our program run efficiently. So here's some common user input errors to check. Range check. Make sure that they're in a possible range of values. Like the value for month should be between 1 and 12, right? We don't have a 13th, 14th, 15th month. So let's examine this code. Birth month equals integer input, enter your birth month number. Then we'll use if-else statements. If it's greater than 0 and less than 13, and we already said it's got to be an integer, greater than 0 and less than 13, that's a great month to be born in. Otherwise, you got to enter a number 1 to 12 of your birth month. So we can use this code just to see if they're actually entering something that works. Let's delete all of that, put this in. I was born in June. That's a great month to be born in. There you go. If we said I was born in Blaluber, yeah, Blaluber is not a month. You got to enter 1 through 12 of your birth month. So using if-else statements just to make sure they entered something usable. How about a reasonable check? Like check any values that are reasonable. Example, age is greater than 16 and age is less than 100. Examine the code below. Age equals enter your age. And we're checking to see it should be between 17 and 99 because we didn't use equals. You meet the age requirements. Please enter your actual age if you put something different. So maybe we're checking to see if somebody wants to rent a car or something like that with our program. We're not going to rent our car to people saying 131. Enter your age. We're not going to rent to a 16-year-old. So if I'm saying I'm 15, it's going to say, please enter your actual age because you've not rented a car. Now, if I'm 17, you meet the age requirements. If I'm 111, okay, enter your actual age. You're not 111 renting a car from us. But if you're 95, maybe you are. You meet the age requirements. But arithmetic. So like example, attempting to divide by 0. Let's look at this code. Try x equals 1 divided by 0. So that's that try command we saw a couple of lessons back. The accept 0 division error. Print, you can't divide by 0. You're silly. So we're telling it to do this division. And we're using that try command. So if it gives an error, it doesn't stop our program. It goes to this accept 0 division error. Can't divide by 0. If we change this to a 10, well, it'll do it. We didn't tell it to print it, though. We could say, I guess underneath here, print X. Run program. Oh, wait. It's not doing it. Oh, I got to back this up. I'm not inside of a main function. Point 1. If I do the 0, it just prints that. You can't divide by 0. Otherwise, it'll go print this number. How about a format check? Don't forget, it was check if a certain date needs to be formatted. Like dates should be days, months, years. Days, months, years. Was this written in the UK? This is not supposed to be curriculum from the UK. We don't write days, months, years. We write it in the month, day in this country. All right, so I'm going to scroll down, copy all that. Let's go here, paste that in here. So it says import date time. That's that module that library module we were looking at. Input date, enter the date in the format month, day, month, year. And now we've got this command that says day, comma, month, comma, year equals input date dot split. So this is putting that in between there so it prints that way. Is it a valid date? Yes or no? So try date time, integer year, integer month, integer day. Except if they enter something that's not valid, it's false. Print input date is valid or it's not valid. So if there's a value error, if there's any error that they didn't enter something that's a valid date, it'll just change this variable is validate to false. Then we're going to use an if-else statement to figure out, did they use a true or false data here? If it's true, if we didn't change it to false, because up here we said we're going to say it's true, it'll say that's a valid date you entered. But if this changes it to false because there was some kind of error, it'll print input date's not valid. So let's see. And it's saying there's a split there because you're supposed to put that in when you, let's run it and see how it does this. So day 22/06, 1960, oh, just 67. Input date not valid. Did I? Let's try this again. Day. Let's do this. 06/06/06. That's valid. Interesting. Let me try this one more time. 22/06/67. Okay, that's valid. I typed something wrong the first time. But if we say we put it in like US format, I said 06/22/67, it wants the month in the middle section. So this should come back and say that's not valid because they're doing it in British way. And I suppose we could change that. Let's see if we can make it work in the US way. Let's change this to month and this to day. And then we're going to change integer month day. Let's break this in. Oh, I hit the wrong button. I'm going to see if just changing that month, day, year, will that work? 06, go to 67. Oh, it's valid. Okay, so we can make it US by just putting this way. Input date. So month, day, and year. So it's saying month, day, and year is 3 variables here. 3 variables. And it's good. We know that this is what's separating them in that input. So we can pull out those variables. The first 2 numbers are going to be the month. The second 2 are going to be the day. The third 2 are going to be the year. And then we check date time, date time, integer, year, month, day. Is that a valid date time? Okay, something we can play with. Think like a programmer. When verifying user input, it is often more user-friendly to have users verify their own input. Like phone numbers can easily be checked for character length, but what if they typed in the wrong number? You wouldn't be able to verify this with more code. Let's see how we can echo users' input so they're able to verify it themselves. That'll be interesting. Okay. So define user prompt. So here's a function that we've created called user prompt. My number input, please enter your 7-digit phone number. Verify equals input you entered, and we're going to type the exact same number back into the input statement and say, is this correct? If they type yes, awesome sauce, thanks for checking. Otherwise, that's okay, let's try again. So let's run this. I'm going to say 282-1384. That was my grandmother's phone number when I was a kid. You entered 282-1384. Is this correct? Yes. Awesome sauce. Thanks for checking. That's pretty cool. What if we say that's not the number? 282-3384. That was my phone number when I first got married. It was almost exactly like my grandmother's. That was cool. It's like, oh, no, I didn't mean to enter that. Okay, let's try again. And then it could go back and do a while loop and repeat again if we need to. But that's just using an input statement. By putting what they typed in that variable, we can put that right into an input statement and ask them if that's correct. So we can use variables inside input statements. We don't just have to type, please enter your 7-digit phone number. All right, page 4. Power of combining user input and conditionals. Combining user input and conditional statements can make your programs quite powerful, almost as powerful as you. However, it takes some practice to hang it out without errors, especially if you have a lot of nested statements. Well, this is part of becoming an experienced programmer. So the more time you make for practice, the better code you're able to write. So let's take a look at this. Define main, Print, 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 print. Welcome to Cinderella's Closet. We buy and sell gently used clothing for teens. Ask the user for input. First name equals input. What's your name? Number, integer input. Enter your phone number with the area code using this format. In other words, no spaces, dashes, anything. And then verify it's the right number. Yes or no. Let's run this. Okay. What is your name? Bob. What's my phone number? 1-2-3-4-5-6-7-8-9-0. There we go. You entered 1-2-3-4-5-6-7-8-9-0. Is this correct? Yep, that's it. Great. Thanks for checking. So we just make sure we have their right name and phone number before they place their order. Let's look at the second slide. Read the code, try to predict the output. Same thing up here. Are you interested in consigning your used clothes? Yes, no. And then how much would you like to earn? Maximum amount of 150. Print results. So open account plus interested. Now interested was, are you interested in consigning your used clothes? How much would you like to earn? And that's the amount we typed up here. If the amount is greater than 0 and less than 151, you're eligible. Otherwise, you didn't enter a proper amount. So let's run this. Checking things are reasonable. Are you interested in consigning your used clothes? Yes. How much would you like to make? $120. How about that? Open account? Yes. Would you like to earn 120? You are eligible. All right. So what if we said no the first time and then said we want to make $1,000? Yeah, we got to enter amount between 1 and 150. So, okay. Well, that's how that works. Let's look at this last page. We're going to run out of time. I'm going to program one students on top of this. User-friendly program. Now that you know how to make decisions, it's time to think like the user. If your user gets frustrated, your program might be confusing. So, for example, you might have written a user prompt, a statement or question used to communicate to the user the input value to enter, that the user does not understand. Ask yourself what the user needs. Yeah, I have those sometimes when people turn in programs and they have an input, but they didn't type anything. It's just a blank box. And I'm like, I don't know what to enter. These days, the usability of a program is almost as important as the program itself. If it's not easy to use, people won't bother. Make sure your program doesn't go ignored and unused. Use these quality tips. Select each card below. When you're finished reading, just drag it off screen to reveal another one. All right, here we go. More effort equals more frustration. Ask, can the amount of effort required from the user be reduced? Do you have too many input statements, too much stuff the user has to do? Does it need all that? Let's get rid of that one. Put yourself in the shoes of the user. What does the user need from the program? Does your program provide what they really need? Simple is often better. What purpose does the feature serve? Is it necessary? Sometimes you're putting stuff in there you don't even need. It's like, we're asking them their age when like age has nothing to do with this. They don't need to tell us their age. Just more stuff they have to do. Think about what the user wants. Is the program meeting the user's expectations? And good programs involve some type of user interaction. How can prompts be as clear as possible? All right, good stuff. The usability of a program does not only refer to the end user. Python's a user-friendly language for programmers too, allowing high effectiveness in meeting objectives. Employability skills, research. When you're on the job, knowing a programming language is only the beginning. There's always going to be more to learn. For example, even though you know how to speak English, that doesn't mean you know every word in the dictionary. Same is true for programming languages. Good programmers will continually research to stay up to date with advances, discover new features, and understand how these apply to various industries in which they're working. All right, so let's look at the assignment because it has the template, but I've got it loaded for us. I'll pull it up in our Google Classroom there. Do This Week in Buzz. So we have a program this week, and here's what it is. Oh, this is an interesting. So you're going to follow the 4 steps in computational thinking to develop and design this program. And it said computational thinking. First, decomposition. We solve a problem by breaking it into smaller groups. We looked at this in the past lesson. So what's a big problem? Let's break it into smaller groups. Then find the order and analyze the data. Pattern recognition. Finally, we have an algorithm design where we create solutions using a series of ordered steps And then generalize and assess. How can your discovery be used? Do that post-mortem review that we do after perm. So part of this they've done for us. Like here it is. Step 1, the decomposition step. This involves identifying the problem and breaking it down into smaller, more manageable steps. So example, a retailer thinks its online sales should be higher. They identify their customers are not making as many large purchases online compared to in the physical store. So looking closer, they identify a lack of $200 and higher purchases. So people aren't spending $200 on the website. They'll just come to the store when they want more than $200. So that's the decomposition of the problem. Here's the pattern recognition. After the problem has been broken down into decomposition step, we need additional data. The retailer recognizes a pattern in online sales. When the purchase price is $200 or more, the shipping costs are quite high. That's why people aren't buying over $200 because it costs so much to ship it, making customers less likely to make these purchases online. Maybe we need some kind of incentive. If you spend more than $200, we'll give you half price on your shipping or something. I don't know. So they've done the decomposition and the pattern recognition. Here's the problem. They're not spending over $200 on the website. We figured out it's because the shipping's so expensive. So now's the algorithmic design. It's where you got some choices. This is where the fun and the assignment really begins. Choose one of these two options. Spend more, get more. Option number 1. You've been hired by the store to write a program that helps improve online sales. The retailer wants to find out how much money customers want to spend, offer a recommendation, and encourage customers to try to spend at least $200 by offering a free gift. Offering a free gift at this price point. So if they spend at least $200, they'll get a free gift. First, ask the customer how much money they'd like to spend. Recommend a product that can be purchased with the amount they're asking for, and then let the customers know how much more money they need to spend in order to get a free gift. Or if their initial purchase is over $200, so they already qualify for the free gift. So this looks like a lot of nested if statements, right? Because we're checking multiple things. Or you can do your own. Choose your own adventure. You can be creative, make up your own scenario. Just make sure it's a shopping related thing that has delivery, sales, accounting, something else that works. Ensure people reading your code understand your scenario, which means make sure you use lots of comments in your code. Follow the requirements described below. So here's the requirements. First, write our pseudocode, but here's what we need to have in our program. To be written in a series of steps that represent algorithmic design. First we'll do this, then we'll do this, and we'll do this. Print a description of your online store for the user to read. Obtain that user input that we talked about up here. Ask the customers. Make sure you use integer, float, and string functions where they're needed. Use the proper order of operations for any calculations on spending. Make sure you have at least one nested if-else statement, which you'll need to meet these requirements. And then provide output based on the user input and the results. So write that in pseudocode because you'll definitely want to figure this out in English before you start writing if-else statements. Welcome to Sock City Shop. Your budget is $55. If you spend $145 more, you qualify for a free gift. With that in mind, we recommend our Sparkle Toe socks made with 100% unicorn hair. You won't want to pass up on this dazzling pair. Thanks for shopping. That's just a little sample of what someone's done. Pseudocode hint. Pseudocode for the example above began with start. They're talking about for this program right here. Start, which represented the main function. The next line said store description, which later turned into a print function when they wrote their code. Then the pseudocode said ask how much the customer wants to spend, which turns out to be the budget. And when you're finished writing the pseudocode, ask yourself if a non-programmer would be able to read it and understand what your program is going to do. So that's just a few hints on some of the pseudocode they did there. So put your pseudocode here. Use comments for internal documentation. Make sure you get the heading with your name, date, description of program. And remember, you can copy and paste a lot of your pseudocode for this internal comments. Define your main function. Indent things correctly. And then when you completed it, make sure you got that zip file or py file that's inside the zip file and the template. And there is the 5 questions at the end. Looks like a fun one. Go play with those if-else nested statements this week. So, all right, guys. Got any problems with that? Questions? We have class Wednesday. But have a great 4-day week. We'll see you guys next week.